This video will combine your knowledge of double triangle trig together with solving systems of equations. All right, this is going to be a doozy of a problem. Let's get started. In the first example, they tell us that there are two boats that are 75 meters apart. The angles of depression from the lighthouse to the furthest ship is 30 degrees and to the closer ship is 45 degrees. And they want us to determine how tall the lighthouse is. So I'm going to go ahead and I'm going to label the height of the lighthouse. For lack of something better, I'm going to label that H. We know that the two boats are 75 meters apart, so that the distance represented by the blue line segment is 75. And like in the previous video, I'm noticing that that segment whose length is 75 doesn't make up the side of any right triangle. We do know that the angles of depression from the lighthouse to the furthest ship. Remember, when you're looking for an angle of depression, or an angle of elevation for that matter, one of the sides must always be horizontal. So in looking out, I'm going to be looking from that horizontal down, and when I'm looking horizontal down to that furthest ship, that angle of depression, is 30 degrees. So let me go label that with a 30. And to the closer ship, again, I have to start with the horizontal. Looking down, that angle is 45 degrees. So if I look at the picture now, I've got what I'm going to call the green triangle, and I don't know the measures of any of the angles except the right angle in that green triangle, but I do know that this angle of depression up here measures 30, and if I follow that transversal down to find his little alternate interior buddy, I know he's got to be 30 as well. And then likewise for the purple triangle, I know that this angle in here, following that transversal down, has to be 45 degrees as well. So if I follow my strategy from the previous lesson, I know that anytime I have these two triangles, the first thing that I need to do is draw them separately from the picture. So I've got this first triangle whose vertical height is h. For lack of something better, I'm going to call this piece here x because I don't know the measurement of that. And I do know the measure of this angle is 45 degrees. And then the other triangle that I want to isolate and look more closely at is this green triangle, again, whose vertical height is h. This distance horizontal is going to be x plus 75. And this angle in here, 30 degrees. So I still have the same three trig functions that I've been using all along. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And in looking at my picture of the purple triangle, it looks like I have the leg opposite and the leg adjacent. So that's going to be a tangent problem. So tangent of 45 degrees is equal to the side opposite h over the side adjacent x. Like before, I'm now going to go to my calculator. I'm going to check my settings and make sure that my settings are set to degrees and to float 12, which they are. And then I'm going to go ahead and open up a new document and calculate the tangent of 45 degrees. Well, that's interesting, and that should make life quite a bit simpler. So the tangent of 45 degrees I'm going to replace with 1. And if I want, I could put 1.0000, but that 1 is an exact value. So I'm just going to leave it as 1. To cross multiply now, x is equal to h. Obviously, that's as far as I can go with the purple triangle. So next, I'm going to go ahead and I'm going to move into the green triangle. In looking at the green triangle, I have this 30-degree angle. I have the leg opposite and the leg adjacent. So like the purple triangle, this is going to be a tangent problem. So tangent of 30 degrees is equal to the leg opposite, which I called h, over the leg adjacent, which is x plus 75. I'm going to head back to my calculator now and type in tangent of 30 degrees. And to 4 decimal places, it's 0.5773. So I'm just going to put the first 4 decimal places on my paper. And that's equal to h over x plus 75. Like before, I'm going to go ahead and I'm going to cross multiply. So h is equal to the 0.5773 number times in parentheses the entire quantity of x plus 75. And so now I notice that h is equal to x. H is also equal to the 0.577 number times the quantity x plus 75. Since both of those values are equal to h, substitution tells me that they must also be equal to one another. So I'm going to go ahead and write an equation now that sets those equal. So x is equal to 0.5773 times the quantity x plus 75. On the right side now, I'm going to go ahead and I'm going to use the distributive property. And when I distribute, I get the 0.577 number times x. And now I need to use my calculator to multiply the 0.57 number times 75. So again, I'm going to go up and I'm going to grab that and I'm going to use the entire value from my calculator, not just the first 4 decimal places. And I wanted to multiply that times 75. So 43.3012. And now I'm going to go ahead and I'm going to solve. I'm going to subtract the 0.5773x from both sides. So I've got 1x minus the 0.5773. So again, when I get my calculator out, I'm doing 1 subtract that entire decimal display from my calculator. So 0.4226 is equal to the 42.3012 number. I'm going to now divide by the 0.4226. So again, when I go into my calculator, I'm not doing just those 4 decimals, but rather I'm doing the entire number from my calculator. So I've got the 43 number divided by the 0.42 number. So 102.4519. So let's go ahead and let's see exactly what it is that I found. 102.4519, if I go back to that picture, that value represents the distance from the lighthouse to the first ship. What I'm trying to actually find in this question isn't the distance from that lighthouse to the first ship, but rather the height of the lighthouse. If I go back there to my system of equations, though, I find that the height of the lighthouse, h, is equal to the value of x. So at this point, I know that x is equal to that number, but so too is h, the height of the lighthouse. And let's go back up and see what this says to round to. How tall is the lighthouse? Ooh, it doesn't say how high to round to or what height to round to. So I'm going to say let's go ahead and let's round this to the nearest meter. So to the nearest meter, the lighthouse is 102 meters high. And I'm going to say is approximately And that'll tell whoever's reading my paper that this is a rounded number. In a question on an assessment, it will always tell you what number to round to. So 102 meters. All right. So there was a lot of really good math going on in that problem, some great trigs, some great algebra with the systems of equations. Like always, I want you to take a few minutes and think and reflect upon what you've seen and heard, and in your own words, summarize the important takeaways from this lesson, and then see if you can use your newfound knowledge to go ahead and solve that problem about Jack and Jill on the next page.